And next up, we have Frossie Economou, and she is going to speak about the Rubin Science Platform on Google, the story so far.
All right, hello. I've been convinced that if I record this, I get to have fun answering questions on Discord. So there better be questions on Discord, or at least statements, or at the very minimum, in-jokes. So I'm here to talk to you about our work deploying the Rubin Science Platform and a number of our other services on our Interim data facility on Google Cloud. Credit to Will for doing all the work, like writing the slides and writing the paper while I was whining about how busy I was. You can tell they're Will slides because they're not in dark mode. All right, let's go. Lots of teams represented in the work referred to here, and I'm very grateful for all of their efforts in contributing to this great enterprise. Rubin NLSST, the legacy survey of space and time, as we have backnamed the original name to. Big survey, 10 years, whole sky observed every twice a week from Sarah Pachon. Image of the field of view compared to the moon. We take one of those every 20 seconds for 10 years. There's going to be a lot of data, very exciting project, and we're very happy to be nearing the finishing line, or at least the starting line for it. So the Interim data facility, the IDF, and how it came about. We started the construction with one data facility at NCSA. Things changed in the funding landscape, and there was a search for a new data facility for operations that was going to be based in a Department of Energy lab. For a while, we did not know where that was. This was creating a lot of uncertainty. There's, of course, schedule risk in kind of pivoting a whole on-prem data center on that timescale. And so we decided, and our management supported us in setting up our data facility on commodity computing, specifically Google Cloud, and using that as a way to just keep going while the US data facility, which has now been awarded to Slack, gets underway. Very important to note that this is not a proof of concept, it's not a cut down kind of experiment, it's not an MVP, it's not a toy, it's not practice, this is an actual production facility. It's actually the most production facility we have because it's the only of our deployments that actually servicing external users. This is an honest-to-God high uptime environment. We don't take it down for maintenance. We preserve service continuity, and we take it very seriously, and really treating it as a real production environment. And it has been a very good experience. We got going very quickly after we signed the contract and have been able to really do quite a lot with it so far. The architecture is reasonably complex because it's a complex system. There are many clusters dedicated to Science Platform and processing and the high-performance database. I'm not going to take you through the whole architecture, but I do want to kind of point out some kind of notable things. We don't use the Google console to set up our infrastructure. We are entirely kind of bought into infrastructure as code. We use Terraform to configure all the computer resources that the production clusters use. That way we get reproducibility, we capture configuration, we can tear things up and bring them up again, and basically practice infrastructure as code. Most of the services are running in Kubernetes. In the case of the Science Platform, they're also managed by Argo CD. Only developers are infrastructure accounts. You don't need a Google account to use the system. In fact, we don't encourage you to do that at all. The Science Platform has its own authentication authorization system, which currently is being backed by GitHub Auth, since a lot of our users already have that. That is obviously not the end game operationally. Data access is through our Generation 3 Butler, which has now finally hit prime time. We're in the process of deprecating the Generation 2 Butler. And in the case of the Interim data facility, the the data stores backing the Butler service are on Google Cloud Storage, Object Store, and the POSIX file systems are backed by Google File Store. We have many other deployments of the Science Platform internally, including at the Telescope Summit, and we have used a number of different ways of backing these. So there's no kind of lock-in here. It's just a choice. It's particularly well suited to this environment. And our own high-performance database layer is also deployed in Kubernetes. That's Qserv. We also use the commodity database service, which is Cloud SQL for Postgres, for relational access for services that need it, like the Butler. Our data preview program is intended to both do an early release of services that are already ready, even though we have not actually reached first slide yet. It's intended to bring on an early kind of slice of the community, including underserved users, to gain experience, give feedback, and allow us to kind of get our materials ready for them, see what they do, guide us in our priorities for development. And so that's already started. Data preview 0.1 was launched in June. It went staggeringly well, really. And I've jinxed it now, haven't I? It's about, 250 users, which is, respectable, but of course it's only a drop in the ocean of the 10,000 users that we eventually expect. Kind of keystone to the user services is the Rubin Science Platform, and this is an entire data side set of services that allow users to interact with data without having to download the petabytes of data that are involved. And so it involves a web portal that is backed by the Firefly team, the notebook aspect backed by the Square team, the API aspect is the VO services that we are currently ramping up. I should point out the notebook aspect does give you access to a Unix command line, so you can do pretty much anything at that point. For DP 0.2, we are once again going to use simulated data provided by the Dark Energy Science Collaboration, but this time, instead of taking the data products as is and just publishing them through our science platform, we are now going to put those data products through our entire data processing infrastructure, process them ourselves. That gives us data with the actual final data model that we expect from our own data, gives those teams an opportunity to rehearse their processes and services. And we're hoping to be online with that in June, so a mere 1 year after DP 0.1. And after that, there is Data Preview 1 and Data Preview 2, which are going to be with actual Rubin data, because we will have that on Sky by then. Pandemic and global catastrophes permitting. It's been really good getting real human beings, not that in-project users aren't real human beings, I hasten to add, but it's been really good to get external users on their services and to see how they're doing. We have a community engagement team that has been very good at supporting those users with tutorials and example notebooks and so on. And we are learning things along the way. Some of them we kind of expected to learn. Some of them have been more of a surprise. The one thing I will say is that your users will find a way of using all the resources available to them. And so you better architect limits to those resources from the beginning. If you give them the ability to spin 1,000 Dask workers, they will spin 1,000 Dask workers. So if you don't want them to do that, you have to figure out in advance how to place limits on activities like that. People very quickly become accustomed to computing always being there. The elasticity of this environment is, of course, one of the major draws. But it also means that your services had better be able to do something while they're twiddling their thumbs waiting for new nodes to be added to your autoscale because you have a surge of user demand. I do not want to underestimate the kind of major importance in having management buy-in. Management has to write you a big check to do this, and it's different from the kind of the business as usual norm. And we have been very lucky to have the support of the entire management chain, up to Bob Blum, our director of operations. I will say that I don't think they have regretted it. I think they have. I think they feel they've gotten their money's worth. Some conclusions about doing this for real on such a scale. I think people have heard me rant about how Kubernetes will save astronomy. I will say that having designed those services from the start to be container orchestration based, made a transition to this environment actually totally painless. There are so many benefits from working in a standardized environment that the entire tech sector is working in. There is so much mitigation that you can do for schedule risk by being able to deploy your services early without waiting for infrastructure to be built. It's not cheap, but it is great value for money. I feel that we got what we paid for. The kind of number of services that you have access in that kind of environment is a great age to velocity. Developers love to self-serve. And so, people always ask about vendor lock-in. Actually, vendor lock-in is not an issue. We use extremely standard technologies that are actually available both on other commodity providers and on-premises. If you actually choose to build your on-prem facilities that way, it's just very easy to accustom yourself to working in an environment where every time you need something, it is there for you. It's gone so well, we're actually seriously evaluating whether, even for actual operations, it is reasonable to design around a hybrid on-premises Google Cloud model. And I will say that there are many considerations here, institutional consideration, funding model considerations, and so on. But from a technical perspective, the one thing I will tell you is that this was really a no-brainer. There is literally no technical reason not to go down this route, and every reason to do so. And so with that, I will tell you that we are making progress. We are rehearsing, and very soon, hopefully, we'll have our own data and we can look at the sky again, and that's going to be awesome. All right. Thank you very much. Hopefully, I've been busy answering questions on Discord at this point.
Thanks very much, Frossie. I can see you have created some mayhem on Discord. I'm not even sure what questions have been answered or not. I don't think you answered Peter's question yet. So Peter is asking, how long do you keep the original raw data? Can you afford to keep it, assuming Google isn't split up, etc.? Yeah, what happens if Google goes under? Inconceivable, I know.
Yeah. Hi, I'm glad everybody's risen to the challenge. I was just trying to type an answer to that one. So technically, because of the way these projects are funded, we have a commitment to keep the data only for the duration of the Rubin operations, which is 10 years. There's actually no, Rubin operations theoretically goes poof at that point. And so that would have been the case whether we were on premises or whether we were on Google. We are, of course, as a project, do not wish the data to go poof after 10 years, and so we are working on various arrangements. I will say that Google is not alone among major providers, that there is a public data set service. So as our data stops being proprietary, we can theoretically host it under the open data set programs that all of these providers have. And of course, also host it to other institutions that want to take it on. Right now, it's like a huge amount of data, but maybe in 10 years' time, it won't seem like that much.
Great. I see a question from Jonathan. I think we have time for one more. Did I hear you mention users spinning up nightmare quantities of Dask threads? And what has your experience been with Dask?
Yeah, so let me say a couple of things about Dask. Now, obviously, when requirements were written for this project back in 2012 or whatever, all these things were a glint in people's eyes. We have tried to stay current with what people really expect and anticipate getting user computing, and I think a very Pythonic, highly parallelizable framework that is next to the data, next to the database, like Dask, is clearly a good idea. So we are working on providing that service. We still have some technical arguments about the best model to implement a Dask service. Right now, the kind of a prototype that we're using allows users to actually spin Dask workers within their own Kubernetes namespace, and that's how we're quoting use of the Dask service, because your Kubernetes namespace is quoted, and therefore you can choose whether to actually spin like a very large instance inside that namespace under your quota, or lots of little Dask workers. It's not part of, Dask is not officially offered as part of Data Preview 0, even though our little bright sparks figured out how to use it anyway. But it will be part of future Data Preview releases. And I think a service like Dask is like super compelling, because it's just the parallelization that it offers for very little expertise in how to correctly utilize parallelization. The fact that you can just do it with one notebook line in Jupyter Notebook is actually very compelling at the scale.
Great, thank you very much. I'm afraid we're out of time, so let's continue this discussion on the channel. I must compliment the fact that you brought a co-pilot, I see. Let's thank all the speakers again.